Discover yourself, who you are, what you can do in your life. Let's ask from brain to think and talk to act accordingly.
Everyone, I welcome you all to this session, in which I am going to talk about recursion in Python. So let's start. In this introductory video, we will briefly go over what the recursion is. Recursion is the fundamental technique of computer science, which can be applied to solve many types of problems. Let's move forward and explain what is the recursive algorithm and what are the conditions with example. So, recursive function breaks the problem down into the smaller problems and calls itself for each of the smaller problems. It includes basically two conditions. First one is boss case or terminal case. Second one is a recursive case. So in other words, depending on what value is passed in, it may return an answer, or it may call itself again. So let's look at the 5 factorial case. Here 5 factorial is 5 times, 4 times, 3 times, 2 times, 1. And what we can see when we analyze that is 4 times 3 times 2 times 1 is actually equal to 4 factorial, so 5 factorial is equal to 5 times 4 factorial. So now when we break down 4 factorial, we could say, well, 4 factorial is equal to 4 times, 3 times, 2 times, 1. But, look, we could say this 3 times 2 times 1 is equal to 3 factorial. So 4 factorial is equal to 4 times 3 factorial. And we can continue doing that until we get all the way down to one of our base cases. And then when we get down to 1 factorial, we say, well, 1 factorial is 1. So we return 1. And then, when you multiply that all out, factorial really lends itself very nicely to using a recursive solution to solve the problem. Because it is really easy to break the problem into the smaller pieces by peeling off the highest number and passing in the next number to call the function again. But, how it works exactly? So, our recursive algorithm looks like this. We call factorial on the 5. The answer is 5 times factorial of 4. We need to get the factorial of 4. So, we call factorial on 4. When passing 4 as the argument, well, get factorial of 4 is equal to 4 times factorial of 3. So each time it is breaking down one more step. And when we get down to the bottom, we say factorial of 1. Well, we know what that is. That's 1. So we can return to 1 at this point. And then we work our way back up. We say, we will get factorial at 1 is equal to 1. And then at this point we can say, well, 1 times 2 is equal to 2. So we pass that up. And then we say 3 times 2 is equal to 6. So pass that 6 up. And then, when we get back up to 5 times factorial 4, we get to 120, which is our final answer. And then we can return the 120, wherever the original function call came from. In other words, we are digging hole ourselves deeper into a hole, and then we do ourselves back out of it by computing our way out of it step by step. So we have all these function calls as we get down into this, and then we close out the function calls when we get to our base case. Let's understand through another example and see how it works step by step. The function's calls are nested, and they are a nice example of stack. The last call return as a first one, and the first call returns as a last one. And output of this example will be I, C, H. So, the recursive algorithm works like this function. Get factorial of n. If n is less than or equal to 1, it return 1. Otherwise we are on return n times get factorial of n minus 1. So this would be like 5 times get factorial of 4, right? That's it. That's how simple they get factorial recursive algorithm. Let's understand through real life example. Recursion function is like a Russian doll. Each time you open a doll, a smaller one will be inside. And you repeat the process until you reach the smallest doll, which does not contain another one. Let's reverse a string using recursion. Recursive function must have an end condition to determine if it should call itself again or not. In this case, if the string is empty, we would not make another recursive call. And here is where the recursion actually happens. The function calls itself with a parameter, which is substring of our string, starting at the index 1. So, what we return is result of our new call, plus the first character of the input string. When it comes to algorithms, every algorithms using recursion can be written to use iteration instead and vice versa. In imperative languages, such as C or Java, due to performance, it is preferred to use iteration over recursion. This does not apply to functional programming languages, where use of recursion is very common. So, what can be recursion used for? It can be used in sorting algorithms, which can be implemented by this. Also used in finding files, in directory structure. Also can be used in parsing XML or HTML file. And that's it. Thanks for watching.